In this second part of our course, I will talk about what are the most fundamental questions related to shallow geothermal energy and its exploitation. I will go into questions like the temperature or the influence of the temperature in the underground, all the different types of systems that could be used and installed in a very broad way. Here, what we can see in the picture is a typical distribution of the temperature with the depth. In the vertical axis, you can see the depth in the left picture. And as we go down and down, we can see here that in different parts of the year, because each of the curve in the colors corresponds to a measurement in our test site in Valencia in different moments of the year, the temperature is stabilizing around this value of between 21 and 23 degrees. It stabilizes as we go more in deep. This is also shown in this other picture, which comprehends about 100 meters. And we can see here this temperature profile, where the upper part, up to 10 meters, is normally termed seasonal fluctuations. So, and as you go deep and deep, you approach the so-called geothermal gradient, which you can see more clear in this other graph. So this temperature gradient is a typical occurrence in our geothermal technology, which we have today into account. What we can see here in the map is what are typical temperatures we can find in different parts of Europe. This map was produced in Project GeoTriNet. And what we can see here is that in heating dominated areas, that means in the north of Europe, we can have temperatures between 2 degrees, the most extreme case in the north, 14 degrees essentially in the center of Europe. And as we go to the south, we can find temperatures even as high as 21, 22 degrees, as we've seen in our graph, in our actual measurements at the Valencia site. So what about the definition of shallow geothermal energy? Fortunately, this was already done in the directive of 2009, where you can see that shallow geothermal energy was defined as the energy stored in the form of heat beneath the surface. And it concerns mainly uppermost part of the Earth's crust. That means up to 400, 500 meters, which is the most depth of some systems. Normally, however, shallow geothermal systems are installed in less than 200 meters in the most cases. There are two ways of harness this type of temperature or resource. We can use the natural temperature of the underground for heating and cooling by means or combination with heat pumps, and this is normally also termed ground source heat pump systems. But we also could aim at change the underground temperature by means of injecting typically heat, for instance, solar heat into the underground to be later used seasonally. And that technology is termed as UTS, or underground thermal energy storage. Here, we also see a range of systems from the horizontal loops, which means systems that are in a very shallow depth, 2-3 meters, or the so-called groundwater wells, which we can extract water from the underground to be coupled to the heat pumps, which typically range up to 50 meters. Borehole heat exchangers, as I told before, up to 250 meters, and also called sometimes vertical loops. We can also use water from mines or tunnels or other underground resources in different types of systems. As you can see, there is a high variety of shallow geothermal systems, and this is one of the features of this technology. It is highly flexible and highly adaptable to different needs and to different conditions. What we, for instance, can see here is different types of systems of shallow geothermal energy utilization. The most widely used is the one we can find here as closed-loop systems. And we can see here from the horizontal system to the piles, which you can see in the center, to the vertical borehole heat exchanger systems. Here, they are also widely used open-loop systems, are these extraction of water from the underground, which is used as a temperature source, and the water is then drawn back to the aquifer through the so-called injection well. We can see also an example where the water from a lake is also used. An ATIS system is a specific class of this type of water-coupled system in which we can use water from different aquifers, making use of the storage capacity of this water mass. And we can find this type of systems, for instance, in the Netherlands quite often. But as I told before, these underground or UTS systems are also a way of storing heat in the underground by means of similar borehole heat exchanger, by which some heat source can be connected to the underground by means of this type of storage.